Welcome to the Math Record. Today I'll be covering the ICTM State 2017 Division AA Junior Senior A person, which I'll be answering questions 10, 17, and 18. As usual, scroll down all 20 questions if you prefer to answer these by yourself, and I'll give the answers at the end. Okay, let's begin with 10. A equals a arithmetic sequence, F equals represents a Fibonacci sequence, and S equals 10, 15, 23, 33, 48, 70, 104 is a sequence where each term is the sum of the corresponding terms from A and F. That is, S of n equals A of n plus F of n for the element of sequence S. 20, determine the 20th term of the arithmetic sequence. So let's just work with the arithmetic sequence first. So let's say the first term is x. That means a common difference, let's say it's d. That means the next one is x plus d, then x plus 2d, then x plus 3d, and the next one is x plus 4d. You could write more if you want, but we could just stop there. And then we have our Fibonacci sequence. So let's say a, b, next one's a plus b, next one's a plus 2b, and the next one's a plus 3b. Well, 2a plus 3b. Okay, so our sum, which they gave us, is 10, 15, 23, 33, and 48, and etc. So basically, how do we solve this? Well, we can make a system of equations. So how many do we need? Well, how many variables we have? We have an x, we have an a, b, and a d. So we have 4 variables, so we need 4 systems. So we need 4 equations. So, 4 equations, not 4 systems. So x plus a equals 10, x plus d plus b equals 15, x plus 2d plus a plus b equals 23. It's a plus. And then x plus 3d plus a plus 2b is 33. Okay, so we're probably not going to use x plus a because there's only 2 variables and it won't really take much away from the others since there's 4. So use this one. So we could take away from the third and the fourth. So then x minus x is 0, 2d minus d is d, and then a, b minus b is 0, so 23 minus 15 is 8. Then use the fourth and the second, so x minus x is 0, 3d minus d is 2d. Then we have an a, 2b minus b is b, and that's equal to 18. So this equation minus this equation, we have 2d minus d is 0, a minus a, d minus 2d minus d is d, a minus a is 0, and then we just have a b, so that's equal to 10. So where do we see this? Well, we see it right here. So that means x plus d plus b is 15. That means if d plus b is 10, that means x is equal to 5. And now we can use this equation because it's only x plus a. So that means if x is 5, that means a is also equal to 5 to make 10. Okay, so now we can look back at this equation. We have d plus a equals 8. We know a is 5, so that means d is equal to 3. And we could stop there because we have our arithmetic sequence. But you want to find d, it's pretty simple. It's right here. So, b. So if d is equal to 3, that means b is equal to 7. But you really don't need to find it. So we want to find the 20th term. The first term is 5. That means 19 more difference. So 19 times 3 will give us our 20th term. So 19 times 3 is 57. 57 plus 6 plus 5 equals 62. So that is our 20th term for arithmetic sequence. Okay, now let's work on number 17. K is equal to 1/3 plus 2, 9 plus 3 over 27 plus 4 over 81, etc. Determine the exact value for K. So we notice that it goes by 1, 2, 3, 4, and then 3, 9, 27, 81. So it's linear on top and geometric on the bottom. So K is a summation that goes on for infinity, started at 1, and it starts at x divided by 3 to the power of x. So it'll be 1 over 3, so when x is equal to 2 is 2 over 9, and then when x is equal to 3, that's 3 over 27, so it kind of matches the equation. So that's just another way to write it. So this is an infinite geometric series, but with a linear on top, so how do we do this? Well, basically, I covered this in my first few videos for my whatever class, which I also covered in a bunch of other ICTM videos. You could split this summation as 2 summations. So x equals n equals 1, both to infinity, and it's going to be 1 3 to the power of x. So working by this, so leave the outside summation alone and work on the inside summation. So first term, so that's 1 over 3 to the power of n, divided by 1 minus the ratio. So 1 minus 1/3 is 2/3. Dividing by 2/3 is the same thing as multiplying by 3 over 2. So this is multiplying by 3 over 2, which you can just move to the outside. Now we can work on this summation, which is the first term, which is 1 over 3 to the power of n, so which is 3 to the power 1, divided by, which is just also 1/3, divided by 1 minus the ratio, and then we still have that 3 over 2. So 3 over 2 times 1 minus 1/3. So this is also just going to be dividing by another 2 over 3, so that's also multiplying by 3 over 2. So multiplying by another 3 over 2 times 1/3. So cancel out the 1/3, that means 3 is on top, and then 2 times 2 is on the bottom, so that's 4. So our answer for number 17 is 3/4. Okay, now number 18. In the diagram not drawn to scale, with ABC with coordinates 10, 12, C which is 8, -2, and point P in the interior of the triangle, the ratio of PAB to PBC to PAC is 1, 4, 5. Determine the order pair of A when the order pair that represents P is 7, 11. Okay, so we have some kind of diagram that I could just draw a general picture of. Okay, and then something like this, and then this. So it's just a general picture, it's not that exact. Then we have 10, 12, 8, -2, and 7 of 11. And then to get this coordinate, let's just call it x comma y. So just the x coordinate and the y coordinate. And the ratio of the areas is 1x to 4x to 5x. Okay, so what we could do is that we could use the shoelace theorem, where we could get one equation based on these two triangles, so the ratio, and then we could get another equation by getting the area of this triangle, and then we could scale it up because this is 4x to 5x plus 4x plus 1x, which is 10x. So it give us the area of this entire thing, because then we could get another equation with x, y using this shoelace theorem. So let's focus on the first one first, which is the ratio of these two triangles. So the first shoelace is going to be 10, 12, and then x comma y. So start with the farthest right and then go counterclockwise. 7, 11, and then 10, 12. So we're going to do 2 by 2 matrices. So 10 times 1 is 10y, and then minus 12x. 11 times x, 11x, minus 7y, and then 12 times 7 is 84, and then 10 times 11 is 110. So if you don't know what I just did there, this is just a shoelace theorem. If you don't know how it works, you could probably just search it up. It's pretty cool. So then we have this is 10y minus 7y, which is 3y. And then 12 and 11 minus x. And then this is also minus 26. And that is the area for this one. Well, half of this is going to be the area of this triangle. That's just the shoelace theorem. Okay, so let's delete this because we don't need it anymore. And I'm just going to move this to the top. Now for this one, so 8, -2, farthest right, so 7, 11, and then x comma y, and 8, -2, so we end it there. So we have 88 minus a -14, which is plus 14, 7y minus 11x, then -2x minus 8y. So then we have our y's, which is -y minus 13x plus a 92 is equal to, well, sorry, 102. And then half of that will equal to the area for this triangle. So we know what the ratio between those two triangles are. It's going to be a 1 to 5. So this area divided by this area is 1 to 5. So cross multiply, we don't need the 1/2 because they cancel each other out. So we have 15y minus 5x minus 130 is equal to negative y minus 13x plus 102. So that means 16y plus 8x and then is equal to 232. Okay, and let's delete this. So what we do is that we can simplify this because I see an 8 and a 16, so we just divide by 8. So that's 2y plus x. So dividing by 8, 8, 16, 24, so we can only go up to 2, so that's 16, which makes 72. So 72 divided by 8 is a 9. Okay, and we have this equation. Now let's get the area of this triangle. So that's just 10, 12, 7, 11, 8, negative 2, and then 10, 12. 110 minus 84, negative 14 minus 88, 96 minus 20 minus negative 20, which is plus 20. So we have a, let's just cancel out with this 20 with this negative 16, which gives us a positive 6. And then this 6 can go with this one to make 102. 100 and so negative 88 and negative 84, that's equal to negative 172. So cancel with this one to make negative 70. So this and this cancel out to make 40. So half of 40 is 20. So the area of this is 20. Okay, so we know the area of this triangle. Since this is 4x, 4x plus 5x plus 1x, that's 10. So the ratio of from this triangle to this triangle is 4 to 10. So reverse it, so 10 to 4. Because the area of this is 20 and we need to scale it up to 10. So 20 divided by 4 is 5. 5 times 10 is 50. So the area of this big triangle is 50. So we have 50 is our area. So using the shoelace theorem, we have 10, 12, x comma y, 8, negative 2, 10, 12. So we have 10y minus 12x, negative 2x minus 8y, and then 96 minus negative 20, which is plus 20. So we have a 2y minus 14x plus 116. Half of that should equal to 100. So multiply by 2 from 50 is equal to, um, so half of that is equal to 50. So then basically twice of that would be 100. So it's equal to 200. Okay, delete. And we have this. So it's probably going to be pretty obvious on how to do this one now. So minus 116 to this side, that means it's negative 16. So we had the first equation subtracted from the second equation. The two y's cancel each other out, so that's 15x. 29 minus negative of 16, that's 45. So that gives us that x is equal to 3. So if x is equal to 3, go back to the first equation. So that will be 3, 23, 29 minus 3 is 26. That means y is equal to a value of 13. So our coordinate is 3, 13. And that is your answer for number 18. Okay, and as promised, here are all your answers for all 20 questions. Well, before we end this video, I just want to say there's two questions here that require calculus, and well, generally calculus, you don't really have to use it, but it's easier with calculus. Number 19 and number 12 and number 4 could require calculus, and number 6. So never mind, 4 questions that require calculus, but I'm not going to cover it in this video because some of them are just kind of basic. Like question 4 is pretty basic. Question 6, while hard, doesn't really take that much effort if you know the equation. And Question 12 is also basic, similar to question 4, but just a little bit harder. And question 19 is also just a basic idea of derivatives, which if someone knows calculus, which is probably a senior, it should be fine. And as promised, here are all your answers. Well, thanks for watching, and I'll see you at the next math record.